Hello everyone, I'm Kazu. I'm so excited talking for many Swift and iOS developers. Today, I will talk about test since I'm a test engineer. I use tasting in my title because my company is food related. At first, I will introduce myself. I'm Kazuaki Matsuo and working at Cookpad as a test engineer and software engineering quality. I've tried test automation for mobile and improve development processes and other some roles to improve several qualities for our services. I develop with some languages in my work such as Swift, Ruby, Java for Android, and Elixir. Recently, I'm maintaining Appium rebinding. Appium is one of the famous mobile test automation tools. Let's go cooking. Even we use the word test, it has a bunch of terms and various meanings. For example, it has categories such as usability test and performance test, and test level such as unit test and an integration test and so on. Today, I pick up test level associated with test automation. Especially, I focus on UI test and how the tests support our development. I won't talk about unit integration level test today. So, you can taste how UI tests support our development and the strategies in our apps as a case study. I'm happy if anyone gets the motivation to consider the test strategy for your apps and try UI test after my talk. Before starting to talk about tests themselves, I'll explain what we are targeting with our tests. Because knowledge for the test target help you understanding test strategies and today's case study. So I explain about Cookpad and its iOS app at first. Cookpad is one of the most famous recipe sharing services in the world. Currently, we provide our services for Japan and countries around the world. According to the SimilarWeb.com, Cookpad is the largest site worldwide in the food category. We also have two kinds of iOS apps. One is for Japan and another is for the rest of the world. Their service growth level is different, so we haven't merged them yet. The global application can be downloaded from any non-Japanese app store. Today's test target is for Japan edition. Japan area is a large market for us, and the app has been developed for a long time. The Japan edition has growth for around 5 years. I'll attach some screenshots to show the growth and the changes. The app changed UI component, added or deleted any features, or refactor implementations during the period. The production code also have growth and it is around 100,000 lines excluded for comment, blank, and new lines right now. In this period, we've released the app many times. Recent our release cycle is around 1 month, and we released around 2 weeks cycle before. We changed source code from around 5,000 to 10,000 per release. The changes have many new features: GUI update, refactor, rewrite to internal logic, and so on. By the way, I also explain a bit about quality. Kano model is one of the famous models to explain about quality. The model has two main qualities. One is must-be quality, and another is attractive quality. Must-be quality is a criteria you must satisfy with as basic needs. Must-be quality in Japan has required crash-free app for almost views and non-degrade features for a long time. Mobile apps environment have been changed quickly through time. OS versions, UI, design, user experiences, required quality by market, and so on. Recently, I sometimes mention such a movement as diachronic quality. This word is influenced by linguistics. Diachronic means sometimes have developed and evolved through time. A bunch of mobile environments has changed through time. So far, I talked the histories of Cookpad iOS app and how long the app have been developed for. In addition, I talked a bit about quality for Japan market and mobile. I start talking how we implement and conduct UI tests to proceed re-engineering our app. This graph shows commit logs for our UI test I've implemented at Cookpad. I've developed the environment since 2014. In 2014, we expected our service needs to develop continuously and we should evolve apps in the future. So, we need to proceed re-engineering for our mobile apps. Re-engineering means restructure the target and make it testable to be able to develop stuff continuously without degrade features and keep development speed, and so on. Writing unit tests before refactoring is sometimes impossible and often pointless. This sentence is quoted from Reengineering legacy software. This is true since we can't check behavior without test. Most of the developers may agree with write refactor features without test lead unexpected broken stuff. In addition, to make the target testable, we should consider architecture for the apps and We approach the proceed re-engineering the app from two aspects, internal and external. Internal means production code side. External means end user and Jira side. I explain a cycle. Check whether GUI behavior are broken from external. And write refactor, implement some features, and implement and conduct unit test. Check the changes from UI side to uncover errors. Developers can find some bugs if their implementations break some other feature unexpected. If tests uncover some bugs, we can fix the issue before release. We'll be able to proceed re-engineering with this cycle step by step. This kind of UI test checking is not only automated test, but also manual checking. The re-engineering also describes the following quotations. Most developers would agree that unit tests should be fully automated. I think most of developers agree with this. But it also describes but the level of automation for other kind of tests, such as integration test, is often much lower. Certainly, implementing automated tests for integration and UI layer is difficult than unit layer, especially mobile app. But one area that cries out for automation is UI testing. Yes, automated UI testing is very important. In many cases, UI test takes too much time and too many human resources in mobile because test automation for mobile is difficult. In engineering, this pyramid calls a test pyramid for ideal test automation. Ideally, amount of unit tests are the largest and the amount of UI tests are the smallest is best. Manual testing is out of pyramid. But in the mobile context, it is easy to make it flip. Checking UIs manually is easy than test automation. But large manual test blocks swift development cycle in the future. Third, converting manual checking to automated UI test and increase unit test is very important. If you succeed increasing automated UI test, you can check automatically most of the layouts, screen transactions, and so on. You can also check combinations of various OS versions and resolutions without additional human resources. Certainly, designing test architecture for test automation is also important. Don't convert all manual tests to dirty automated tests. This graph is crash count from iTunes Connect in our app. According to the graph, the crash rate has been decreasing, even increasing in all app versions. Before 2015, this graph was more high. We keep releasing our app during this period. In addition, our development have become more active. This result shows we achieve decreasing crash rate and write refactor and any improvement features. Let's see implement the strategy. We've been developing UI tests since 2014 to support reengineering. Before, we had many manual tests and non-automated UI tests. But currently, we have many UI tests which cover around 80% screen transaction and spot manual testing. Our architecture for the manual automated UI test is like this. We separate some layer to divide responsibilities for scenarios associated with end users and product code associated with the iOS framework. This architecture keeps the independencies between end user scenario and concrete implementations depends on iOS framework. Thus, we can decrease maintenance costs for scenario side and iOS side. This is an example to describe scenarios. I implement scenarios with data-driven testing style with Turnip. Turnip allows us to describe tests with natural language. This scenario is close to end user. So I choose the natural language to describe the scenario then. This is steps and wrappers to convert natural language to programming languages. This example is implemented by Ruby. These two layers are fundamentals for UI test. I share some tips to season the test. It is important to describe test scenarios independent of internal logic for production code. For example, this find elements method tries to find out elements with XPath. XPath indicates a view hierarchy. But this finding elements will be broken easy if OS version is updated. Because the path strongly depends on the iOS framework's logic. So use accessibility identifier or a label to avoid this kind of cause. And test for all boundaries is better to implement in the unit test. For example, validations for text field. Because UI test is too slow than the unit test. So if you implement all boundaries in UI side, it is better to move test from UI level to method level and remove it from UI side in the future. More spice to extend UI test we've tried. I just explained about scenarios and its implementations for UI test. But test automation is not only describing scenarios, but also judgment results and report it. For example, we also implement image diff to judge the result and feedback to designers. Designers can know the difference between the previous version and the new version easily. This helps layer checking. This example shows the diff on system alert. The diff was caused only for iOS 8.1 when we refactored some internal logic before. And we also capture network traffic for particular scenarios to uncover unexpected requests in them. We can uncover unexpected burst requests and server loads. Keeping this kind of UI test or other spices encourage developers rewrite, refactor, and introduce new tests. If their change broke some features, UI test can uncover the errors because our UI tests cover around 80% screen transactions. We started to introduce Swift into the app a few months ago. Near 30% code is already implemented in Swift for our application. Also, in this case, tests make developers confident changes in UI request level. Current UI tests are enough for current our development processes, but our team will become bigger than now in the future. So, I will introduce alternative tools such as XUI test or Algray for UI test partially. But we don't stop using RPM because their responsibility area and the test framework's lifecycle is different. I talked about histories of Cookpad app and how we've tried to re-engineering the big app with the automated UI test. UI tests need to separate the responsibilities from production code to catch up with some changes painless. Do you get motivations to challenge automated UI test? But don't forget this kind of challenge can't do in developers' spare time. Certainly, some required skills are similar for each other, but software test and test automation needs a bit different skills and techniques. Thanks for listening to my talk.
お話ありがとうございます。以前 RPM を使っていて、RPM の起動と1回の UI テストに時間がすごいかかっていて、メンテコストがすごい高かったんですけど、UI テスティングではなく RPM を選択した理由があったら教えてください。
はい、まず日本語で、RPM を選択した理由としては、RPM は、例えばシステムアラート、シミュレーターの状態を毎回クリーンにしてシステムアラートを出すということができるツール、形になっているので、シナリオの再現性っていう意味で RPM を使い始めました。例えば XCY テストだとシステムアラートは1回出すとその後もう1回出すことが、その XCY テストのフレームワークのライフサイクルだとできない。そういうふうな、少し外部の環境も考慮して RPM を使うっていうことをしました。おっしゃる通り遅さはあるんですけれど、私たちは例えば CI 上でパーコミットで UI テストを回してるとかっていうことはしていなくて、そこら辺はどのタイミングでどういうテストでリリースをカバーしていくかというふうな少し違ったストラテジーを考えないといけない領域になるので、そことは、そういうふうにいつ何をやるかということと、どういうテストができることっていうのは分けて、選択をして RPM というのを選びました。
ありがとうございます。
Hi, you mentioned that we should not do all the boundary tests because UI testing is slow. So I would like to know what kind of case is most worthy to test.
Thank you. そうですね。バウンダリーのテストでやっぱり多いのは入力文字を、 例えば、20文字入力できる、20文字しか入力できないところを、19文字入力したり、21字入力したり、もっと多くの文字を入力をしたりっていう風なバリデーションに関わるところとかは、UI のテストでやってもいいんですけれど、そういうふうにバリデーションにアウトかどうかっていうものは UI のところで全てケースを揃えると、そこに至るまでのいろんなステップとかが重くなるので、よくあるけれど、なるべくニットテスト側でバリデーションやった方がいいっていう例が、そういうのは文字入力のところになりますね。